In grade 10, you solved inequalities for polynomials. Now, a polynomial, when factorized, only has factors in the numerator. This year, we're going to take a look at inequalities for rational functions. A rational function is a function which is represented with a fraction. Now, if I was doing an equation, I would want to know where I had zeros. But when I'm doing an inequality, I want to, in addition to knowing the zeros, I want to know where my graph could have been above the zero line or below the y equals 0 line. In order to do that, I'm going to make sure that my factors, my expressions, are fully factorized and that my factors have the x term first. In this example, you will see that in the numerator, that is already the case. That is a linear expression, and it is, in fact, fully factorized. In the denominator, though, if I take a look at that expression, the x term is second. So in my first step, I'm going to change those terms around in the denominator by taking out a highest common factor of -1. In other words, I'm still going to have 2x minus 1 in the numerator, but in my denominator, I'm going to have minus x minus 5. If I divide both the left-hand side and the right-hand side now by -1, the -1 on the left-hand side is going to be cancelled. 0 divided by -1 is still 0, but because I have an inequality and I've divided by a negative number, I must change my inequality sign around. So in this next step, you can see that the only difference from what I had before is that when the minuses are cancelled out, my sign, my inequality sign, is the opposite of what I had before. This is the step that you must look at in order to set up your number line. If I put my number line together, I want to make sure that I have all the factors that are represented over here. So I need to know what my critical values will be. The critical values must be read off the top and the bottom of the fraction. And so the critical values that I have over here are going to be when x is going to be equal to 1/2, and in fact as well when x is going to be 5. Now, as when x is 5 is in the denominator of my fraction, and I can never ever have a 0 in a denominator, that critical value can never be included. So if I represent them on my number line, immediately when I write down 5, I'm going to make that an open circle because I know that I'm not allowed to use that value. And now, because I have my linear factors and I have x's at the beginning of each of those factors, and there is no constant coefficient of -1 in that fraction, I'm allowed to use the method where I say always start on the right-hand side interval first. It'll always be a plus. If your factor had not been repeated, you do not repeat the sign. So I start with a plus, my next interval must be the opposite sign, a minus, and the next interval, once again, the opposite sign, which is a plus. As I'm looking for the intervals that are represented, shown in my last expression over here, where my inequality sign was less than or equal to, I want to know the intervals that are represented with the minus. In other words, I want this interval in the middle over here. But note, I don't only want the minus interval, I must also include the 0 for the factor that was represented in the numerator. I have already told you that you cannot use the critical value when x is 5, because that would have given you a 0 in your denominator. And so finally, if I write this up using interval notation, the x values that I was allowed to use belonged to the set that started and included 1/2 and went all the way up to 5, but excluded the critical value of 5.